Okay, so we're going to continue on from where we left off in the last video. We're going to start with question 11, and there's a link as well to question 10 when we start here, and we'll see it as we go through. But if the molecular weight of substance X used in the previous question was 212, so immediately I'm going to write down that 1 molar is equal to 212 grams in a litre of substance X. Right? What's the molarity of the previous solution from question 10, given that it had a concentration of 10.68 grams per litre? So, question mark, what's the molarity of 10.68 grams per litre? So some of you are going to cross multiply and be able to calculate it. I've mentioned before how I do it. I'm going to take my 212 and I'm going to divide this by 212 on the right hand side of the equal sign, and I'm going to multiply it by 10.68, and I'm going to do the same thing on the left hand side. So if I do it on the right hand side, I get my 10.68 grams per litre, right? Divide by 212 times 10.68. But if I do it on the other side, I just get my calculator and take 1 divided by 212 and multiply that by 10.68. So exactly the same on the left and the right. I get an answer, and I get 0.05 molar. So I know now that this concentration of 10.68 grams of this substance X in a litre gives you 0.05 molar. So the answer will be 0.05 molar for question 11. Alright, so we'll move on to question 12. And we'll say with question 12, it says the molecular weight of glucose is 180. So again, I know my equation. 1 molar equals 180 grams per litre. Okay. It says express a blood glucose concentration of 80 milligrams per 100 ml as a molarity. Now whenever I see molarity, I'm always thinking litre. So if I have 80 milligrams in 100 mils, well, if I wanted to see how much was in a litre, it'd be 800 milligrams in a litre, or 1,000 mils, right? And that's the same as saying 0.8 grams per litre. So the question is, what's the molarity of 0.8 grams per litre? Okay, so if we know that information in this question, we can kind of move this, give a bit more space, and we can say, what's the molarity of 0.8 grams in a litre? Alright, so how can we work that out? Well, we already know that 1 molar was equal to 180 grams per litre. So we've done this in the last question. We're going to divide by 180 on this side and multiply by 0.8. And I'm going to do the same thing on the left hand side. So if I get my calculator and say 1 divided by 180, and I'm going to multiply it then by 0.8, and I get an answer of 0.00444444, and so on. Molarity is equal to 0.8 grams per litre. So the molarity of, in that question, was glucose, 0.0044 molar will be equal to the 0.8 grams. Alright, and some people might say, well, that's the same as saying 4.4 millimolar. Depends on how you're asked, but it's the same way. I'm just dividing by 1,000 if you want it in millimoles. So that's question 12. Question 13, we'll go to it. So question 13 says, the molecular weight of hemoglobin is 64,000. So straight away I'm going to write down what we're very familiar with by this stage. 1 molar equals 64,000 grams per litre. What's the concentration of a 5 micromolar solution, right, expressed in milligrams per mil? So let's leave the expressed in milligrams per mil till the end. We'll work out the 5 micromolar first. So I'm going to do my trick again that I told you about. 1 micromolar, okay, is equal to 64,000 micrograms per litre. Right, so you see I just put in the micro either side. Right, so it keeps everything the same. You've 1,000 times less the molarity, and you have 1,000 times less the amount of hemoglobin being added into the litre. So that's 1. So the question said 5 micromolar. So 5 micromolar is equal to, so if I take my calculator, 64,000 times 5 is equal to 320,000 micrograms in a litre. And the question asked what was the molarity in milligrams per mil, right? Milligrams per mil. So we have to look at both here. So you know first, if we look at the volume, there's 1,000 milliliters in a litre. So to get it per milliliter, we have to divide it by 1,000. So let's do that first. We know 5 micromolar again is going to be equal to 320 micrograms in a mil. So you see what I've done there? I divided by 1,000 because I've gone from a litre to a mil. And by going in that factor of 1,000, I've divided by 1,000. So now the question asked for milligrams per mil. So 5 micromolar, right, is equal to milli now. So I want to get to milli, which is dividing by 1,000 again. So it's going to be 0.32 milligrams per mil. Right? So I'm just dividing by the 1,000 there to get the 0.32. So the answer is 5, the micromolar of the hemoglobin will be equal to 0.32 milligrams per mil. So not only did we answer the question correctly, but we've also provided the correct units. Okay, so question 14. This is going to bring together two aspects of things we've been talking about so far. But initially, we know it says it here, the molecular weight of glucose is 180. So we can write down again that 1 molar is equal to 180 grams per litre. Okay. Then the second part of the question says that 500 mils of a 10% weight per volume solution is made up. So if we know already the equation that 1% is equal to 1 grams in 100 mils. So 10% is equal to 10 grams in 100 mils. And the question specified that 500 mils was made up of this buffer. So that means that for 500 mils, you'd have 5 times this in 500 mils, right? Because it's 5 times the volume. So 50 grams in 100 mils, and the question refers to the molar concentration, so molarity. So we have to work out what the molarity of the solution is. So let's get it to litre. This is the same thing as saying 100 grams in a litre, right? Because there's 1,000 mils in a litre. So if we go to the molar side of the question, what's the molarity of 100 grams in a litre? Okay, and that's the main crux of it. So I'm going to do my normal setup here, where we are going to divide by the 180 that I select here. I'm going to divide it by 180 multiplied by 100 to get this side sorted, right? And I'll do the same thing to the 1 number here, divided by 180 multiplied by 100, and we'll see what the answer is. So if I get the calculator and I say 1 divided by 180 and I multiply it by 100, I get 0.555 and so on, it's all 5s. Molarity is equal to 100 grams per litre. So that kind of really sets the scene for our molar concentration of the solution. And what the question says is that you have a certain, say, bottle with 500 mils of this 10% solution, and you know now the concentration in moles is 0.555 molar, and 100 is removed from this, which means that we are left with the same bottle but with a lower volume, we'll say 400 mils. So the question was, what is the molar concentration of the solution that remains in the 400? And we've taken out 100 mils. However, this doesn't affect the concentration. Even though 100 is gone, the volume has gone down, but the concentration hasn't changed. It's still the same. It's 10% in weight per volume, or you could still say it's 0.55 molar in that 500 mil and the 400 mil and the 100 mil. It's just that the volume has decreased, but the concentration stays the same. So the answer to the question, what's the molar concentration remaining, is this here. This one here, 0.55 molar. Okay, that's the question answered. It stays the same. Okay, so that finishes question 14, and it leaves us with just 6 more to do. So we'll finish this tutorial here, and we'll do the rest in the next one.